Hello everyone. In this video, we are going to discuss about Theorem 6.1, which is actually known as Basic Proportionality Theorem or Thales Theorem. See, according to this theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. That is, to explain this theorem, let us just consider a triangle ABC. We are considering a triangle ABC. Now, let us draw a line which is parallel to this side BC of the triangle. So, I am just drawing a line which is parallel to this side BC of this triangle. And I am naming this point as DE. So, you see we have just drawn a line DE which is parallel to this side BC of this triangle ABC. So, you see this line DE intersects the side AB at this point D, and this line DE intersects the side AC at this point E. Now, according to this theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So, you see this line DE intersects this side AB as well as this side AC. Okay, in these two distinct points D and E. So, the sides are divided in the same ratio. That is what this theorem tells us. That is, the sides are divided in the same ratio means AD divided by DB. The ratio of these two, that is AD divided by DB, that will be equal to AE divided by EC. AE divided by EC. Okay, so we need to prove that AD divided by this ratio, AD divided by DB is equal to AE divided by EC. We want to prove this. Now, let us just join these 2 points B and E. I am just joining these 2 points B and E using a blue color dotted line. Okay, and let us just join, these 2 points C and D. So, I am just joining these 2 points C and D by using a violet colored dot line. Okay, now let us just draw a perpendicular line from D to this side AC of the triangle. That is, I am just going to draw a perpendicular line from D, okay, to this side AC of the triangle. That is, this angle is 90 and I am naming this point as M. Alright. Now, let us draw another perpendicular line from E. Okay, that makes 90 degree angle with this side AB of the triangle. So, I am just drawing a perpendicular line from E. Okay, which makes 90 degree angle with this side AB of the triangle. Okay, that is, we have just drawn DM perpendicular AC. Okay, the line DM is perpendicular to this side AC. Then we have just drawn E. I'm naming this point as EN. N. So EN perpendicular to this side AB. Okay. Now, let us just consider this triangle ADE. That is this triangle ADE. We are considering this triangle ADE. Area of this triangle ADE, it is represented like this. AR for area, area of triangle ADE. This is actually equal to what? Half into base into height. Okay, that is 1 upon 2 into base into height will give you the area of this triangle ADE. Okay, so area of this triangle ADE will be equal to 1 upon 2 or half into base of the triangle. I am taking this as the base now. So, AD, okay, into height of the triangle, that is EN. Alright, so area of ADE, this is equal to half into AD into EN. I am taking this as equation number 1. Similarly, when you consider this triangle BDE, see BDE, DE. I am considering this triangle BDE. Okay, so here the area of this triangle BDE, that will be equal to half into base into height. Okay, I am considering this triangle BDE. So half into base into height. So half into, okay, base, I am taking DB as the base here. So DB into height, which is EN for this triangle EN. Why I have just taken EN as the height for this triangle BDE? Because height of a triangle, it is perpendicular to the base. So you see EN is the height which is actually perpendicular to the base. That is, base of this triangle is DB. So when we extend this line, we get this side AB. So this EN is perpendicular to the base. Okay, so area of BDE will be equal to half into DB into EN. I am taking this as equation number 2. Similarly, let us just again consider this triangle ADE. ADE. Okay, the area of this triangle can also be expressed as half into base into height. So in the first case, we have considered AD as the base and EN as the height. So when you consider this triangle ADE, you can consider now, you can consider this AE as the base and DM as the height. Okay, so half into AE into DM. I am taking this as equation number 3. Similarly, when you consider this triangle DEC, see DEC, we are considering this triangle DEC. When we consider this triangle, its area will be equal to half into, okay, base into height. So half into, I am taking base as EC. So EC into height. Okay, EC into height. You see DM, which is the line perpendicular to the base. Height is the line which is perpendicular to the base. So we have considered this EC as the EC as the base of this triangle DEC. So the line perpendicular to the base, which is DM. So EC into DM. I am taking this as equation number 4. Okay. So you see, we got the area of ADE, triangle ADE, as half into AD into EN. We got the area of this triangle BDE, we got it as half into DB into EN. Then area of this triangle ADE, that can also be written as half into AE into DM. And when we consider this triangle DEC, area of this triangle DEC, that is equal to half into EC into DM. Now we are going to take these 4 equations 1, 2, 3 and 4, and we are going to find the ratio, that is ratio of equation number 1 and equation number 2, as well as the ratio of equation number 3 and equation number 4. So when you take the ratio of equation number 1 and equation number 2, see, equation number 1, we have area of ADE. This is equal to half into AD into EN divided by equation number 2, which is area of BDE. This is equal to half into DB into EN. Okay, see, half can be cancelled, EN cancelled. So we are getting area of ADE divided by area of BDE as AD divided by DB, and I am taking this as equation number 5. Okay, similarly, when you take the ratio of equation number 3 and equation number 4, we can write area of triangle ADE divided by area of this triangle DEC. This is equal to area of the triangle ADE is half into AE into DM divided by DEC. It is half into EC into DM. Half can be cancelled, DM cancelled. So we are getting it as AE divided by EC, and I am taking this as equation number 6. Okay, so we got the ratio of these two as like this. Now, if you consider this triangle BDE, see, consider this triangle BDE, okay, and triangle DEC, okay, triangle DEC, okay, we are considering this triangle BDE and this triangle DEC. You see, these two triangles have the same base, DE. Okay, for the triangle BDE, we have the base DE. For the triangle DEC, we have the base DE. So these two triangles have the same base DE, and these two triangles are between the same parallel lines BC and DE. So these two triangles BDE and DEC have the same base DE, and these two triangles are between the two parallel lines BC and DE. So in 9th standard you have learned that for such two triangles which are having the same base and between the same two parallel lines, the area of this triangle BDE will be equal to the area of this triangle DEC. Okay, area of this triangle BDE will be equal to the area of this triangle DEC. So area of triangle BDE will be equal to area of triangle DEC. So when you consider these two equations, here in the numerator we have area of ADE, area of ADE, numerator same. When you consider the denominator, here we have area of BDE and here we have area of DEC. See, these two are the same. That means the left hand sides of these two equations 5 and 6 are the same. So we can equate their right hand sides. When we equate their right hand sides, we can write AD divided by DB, which is equal to AE divided by EC. Hence, we proved this theorem. Because you see, according to this theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. That is AD divided by DB is equal to AE divided by EC, and we have proved this theorem. Okay, I hope it is clear to you. Thank you.